Hello, welcome back to Mr. Miles Maths. This is our second lesson on solving linear equations. If you haven't watched the first one already, I would certainly recommend it because this is a development of those kind of ideas. And a quick recap of what those ideas are. When we're solving equations, remember, we always have a left-hand side and a right-hand side, and at the start of the question, they are the same. That's what equals means. Left-hand side equals right-hand side, they are the same. So the things I have to bear in mind is that I should always have a left, I should always have a right. The equal signs go down the page. I should always write them going down. And I should always keep the left-hand side and the right-hand side separate because of that. And also, because they are the same at the start, I must do the same thing to both sides. So if I do something to the left-hand side, I must do exactly the same to the right-hand side and vice versa. I can do whatever I want to one side, so long as I balance it so that I'm doing the same to the other side, it will always work. So these questions, we're going to look at examples involving some fractions, so solving equations with some fractions, and also incorporate the ideas. It'll be a bit of revision of the first lesson as well, because that's how this topic kind of works. So first question, x over 3 equals 6. So we've not looked at any yet where we have a division. X over 3 means x divided by 3, but the principles are the same. We've looked at ones where we've had plus and minuses and timeses, and we always have to do the opposite in order to get the x by itself. Remember, when we're solving an equation, the whole principle, the final outcome that we want is that we want to get the x by itself. X equals at the end, then we've got our answer. Solve for x means find the value of x. So in this question, x over 3 means we are dividing by 3. And so to get rid of that division by 3, we want to do the opposite. And again, notice how I'm focusing on the full x term, because that's the bit that's going to help me get closer to just the x by itself. So because there is a division by 3, to cancel that, I'm going to multiply the left-hand side by 3. And that will just leave me with x. Equal signs line up. But because I've times the left-hand side by 3, I've got to make sure I times the right-hand side by 3 as well to balance things back out. So that means I'll do 6 times 3, which will give me 18. X equals 18. Makes sense? 18 divided by 3 is 6. But we don't want to just think, well, what do we need to divide 3 by to get 6? Have the process and the principles in place, because then when it gets more difficult and we start to come on later videos like lessons 4, 5, 6, and possibly more, so much excitement ahead, then you'll have all the proper principles in place and you will be able to approach those more difficult questions. Okay, number 2. So nice and quick, x over 9 equals 5. Find our x term, x over 9. There it is. That dictates what we do. Forget what's on the other side, doesn't matter for now. We've got division by 9, so to cancel that, we're going to multiply the left-hand side by 9, which means we have to multiply the right-hand side by 9 to balance out, keeping size the same. Think of those scales we talked about. Times one side by 9, they're not level, they're not equal. If I times the other side by 9, they're back level again. So I times the left by 9, it'll cancel as the division by 9, and the x will just pop out nicely. But I've got to times the right by 9 as well. 5 times 9 gives me 45. X equals 45. Number 3. Okay, let's mix it up very slightly. People get confused when you change the letter. People get confused when you change the side. Should be no reason to let this worry you. We're still just focusing on where the unknown is. The letter is the unknown, the thing I don't know the value of yet, which is the a. The term that's in is a over 7. So if I want to get that a by itself, I need to get rid of that division by 7. So I need to multiply the right-hand side by 7. But if I do that to the right, I've got to do exactly the same to the left. So I've got to multiply that by 7 too. So when I multiply the right-hand side by 7, I'll just get a because it cancels the division by 7. And I multiply the left-hand side by 7. 2 times 7 is 14. And then we want to know what a is. We don't want to know what 14 is. We already know what 14 is. So we always write the a first. A equals 14. Notice how it doesn't matter that the letters A still works the same way. It doesn't matter that it's on the right-hand side. You look at what is around the A and how you're going to get rid of that, and that's why it's kind of a bit like a puzzle. 11 equals C over 4. Last one of this type. So we have a division by 4 happening here. C divided by 4. So to get rid of that division by 4, I'm going to multiply the right-hand side by 4. And to balance that back out, that means I need to multiply the left-hand side by 4. So I'll get just the C on the right-hand side, perfect, because that's what we want. The timesing by 4 gets rid of the division by 4, but I've got to times the left by 4. 11 times 4 is 44. And then rearrange to get the C at the start, and the job done. So they're all with just kind of one-step equations with fractions. These are now going to be some two-step equations with fractions. So we've got 5x over 2 equals 10. Now, fractions are a little bit ugly when we come to solving equations. I was always taught to get rid of the fractions as soon as possible by multiplying up by that number on the bottom to cancel that division. There are different ways of doing this, but that's strongly what I would recommend doing here. So the first thing I do is identify my x term, the term with the unknown in, and I think, how can I get rid of that division by 2? So just like we've done the earlier questions, to get rid of that division by 2 on the left, we're going to multiply by 2, which means we have to multiply the right-hand side by 2 as well. So multiply the left by 2, I will just be left with 5x. The multiplication by 2 just cancels the division by 2. Got to multiply the right-hand side by 2, 10 times 2, which is 20. And then, if you remember from the first video, if you've watched the first video on solving equations, if you've got 5x, that means 5 multiplied by x. So to get rid of this 5 in the 5 times x, I want to divide that left-hand side by 5, which means I have to balance it by dividing the right-hand side by 5. Divide the left by 5, the x will just drop out, it cancels that multiplication by 5. Divide the right-hand side by 5, 20 divided by 5 is 4. X equals 4. So 2 steps, because we've got those 2 calculations to do. Number 6, 6 equals 3y over 5. So again, just change the letter, doesn't make any difference to our principles or how we're going to consider this question. Still going to approach it exactly the same way, and also the y's on the other side, but that doesn't matter. All I do is find my unknown term, 3y over 5. To clear that fraction, to clear the fraction means to get rid of the bottom. To clear the fraction, we'll multiply the right-hand side by 5 to cancel that division by 5, but I've got to multiply the left by 5 as well. And when I do that, I will get 30 on the left, 6 times 5, and I'll get 3y on the right, because I'll be multiplying by 5, which will cancel the division by 5. Just realised I put my division by 5 on the wrong line on the line above. Let me just change that so it's all nice and consistent in case you're pausing the video. 30 equals 3y, back to this question. So to get rid of that multiplication by 3, where's my y? Here it is. I've got 3y, 3 times by y. So to get rid of 3 times y, I'm going to divide by 3 on both sides. So when I divide the left by 3, I get 10. I divide the right by 3, I get y. And again, I should just rearrange it so the y comes first. When the y comes first, we call y the subject of the formula. So the subject means it's the first thing. A few more examples, and then we'll change the style slightly. So 2x over 9 equals 4. So again, identify your x term. The one with the x in it shouldn't be that difficult. 2x over 9 equals 4. To get rid of that division by 9, 9 is on the bottom, that means I'm dividing by it. I need to multiply the left-hand side by 9. And whatever I do to the left, I do exactly the same to the right. So times that by 9 too. So 2x over 9 times 9 will cancel the division by 9, so I'm just left with 2x. On the right-hand side, I'll get 4 times 9, which is 36. And then again, to get rid of that multiplication by 2 times x, I need to divide by 2 on both sides. So the x drops out nicely, and 36 divided by 2 is just 18. Notice how I never really think about what's on the other side to the x at the moment, not with these kind of questions. The x is the important thing. That's the thing I want to get by itself. So the things around the x, they dictate what you're doing. That 4 on the right-hand side here could be anything. Could be 5, could be 7, could be 1,000. Doesn't really matter. It's this 9 near the x, the division by 9, to get rid of that times by 9. That's what's telling me what I need to do. Okay, let's change the style again slightly. So let's have fractions, and rather than the multiplication at the same time, let's have some addition and subtraction. So c over 4 plus 2 equals 5. And you may have noticed in the first video, I did draw a green line to make my equal signs line up. I'm omitting that now, but it's kind of still there, splitting the left-hand side and the right-hand side. So c over 4 plus 2. Now, there's a couple of ways of solving this. I'm going to give you both ways. I think it's good to have different approaches, and if you can do both, you understand the principles properly. So the first thing to do is identify our unknown term, which is c over 4. And we want to get that c over 4, we want to get that c by itself. So the first thing I'll probably look at is looking at, well, that plus 2 on this side, I don't want the plus 2 to be on that side because it's quite loosely attached. I can subtract 2 to get rid of the plus 2, and I must do that from both the left and the right hand side. So I subtract 2 from the left, it cancels the addition of 2, this bit here. That minus 2 is nothing, so it cancels out. I'm just left with c over 4, but I've got to subtract 2 from the right hand side as well. 5 minus 2 gives me 3. And then I'm back to the kind of first questions we looked at today. To get rid of that division by 4, I need to multiply the left hand side by 4. Got to multiply the right hand side by 4 as well to balance it. Left hand side times 4, the c just pops out. I clear the division by 4, but I've got to times the right by 4. 3 4s are 12. So that's one way of doing question 8. I'll have a little look at an alternative method for 8, and some of you might prefer this. I used to when I was taught this, but then I realized it's good just to have all the options, and the other ways perhaps a little bit easier not to make a mistake on. So some people here like to think, well, this is the term that I've got, c over 4. So in order to get the c by itself, I'm gonna have to times by 4, and that's completely true and completely fine. You just have to be a little bit careful if you take this approach, because if I times by 4 on the left-hand side and times by 4 on the right-hand side to balance it out, that's all well and good, but I've got to make sure I don't forget this plus 2 term, this extra term. When I times the left-hand side, this whole side by 4, I have to times every term by 4. So not only do I times the c over 4 by 4, which will just give me c because it cancels the division, I also have to times the 2 by 4 to give me 8. And I've got to times the other side by 4. 5 times 4 gives me 20. People sometimes forget to multiply this. Whenever I multiply up in an equation, I multiply every term on both sides. So the whole of the left-hand side gets times by 4 and the whole of the right-hand side gets times by 4. And then from here, to get rid of that 8, I can minus 8, do the opposite of plus 8, which is minus 8 to both sides. So the c will drop out and I'll do 20 minus 12. Notice I get exactly the same answer in both cases. So either method is fine. It's good to be able to understand both and hope you can see why both methods work. But the second method, sometimes people forget to multiply the 2 by the 4 as well in this case. Sometimes multiplication first will work better. In this case, I'd probably say subtracting is a little bit easier because it will avoid that mistake for you. Okay, a couple more questions. Number 9, 3 plus e over 8 equals 7. So I will do the first method here. So first thing I'm going to do is get rid of the things most loosely attached to the e, which is the 3, which is positive 3. So to get rid of positive 3, I'll subtract 3 from the left, which means I've got to subtract 3 from the right. This leaves me with e over 8 on the left, because it gets rid of the 3 at the start, but I've got to do 7 minus 3 to give me 4 on this side. And then again, to get rid of that division by 8, I'm going to multiply by 8 on the left, which means I have to multiply by 8 on the right. So the e comes out nicely, the 8's cancel, division by 8 and times by 8 cancel. 4 times 8 is 32. If you're preferring the other way, I will just run through it quickly. So here I would multiply everything by 8 to clear the fraction right from the get-go. That division by 8 is what dictates that. That will help me get to the e. So I have to times 3 by 8, the second term by 8, which just cancels the division by 8, and then 7 8s are 56. Then subtract 24 from both sides, because that will just leave me with the e if I get rid of that 24. So I'll get e equals 32. Same answer, both techniques, very valid, both techniques, absolutely correct. Number 10. So 10 is 6 equals 2x over 3 minus 2. So I've just added an extra little bit into this, and then we'll do one more question after this. So again, find where your x term is. This is the thing I want to get by itself. So I need to get rid of that minus 2. And I get rid of minus 2 by adding 2 to both sides. When I add 2 to the left, 6 plus 2 is 8. When I add 2 to the right, it just cancels the minus 2, and I'll get 2x over 3. Now we need to get rid of the division by 3. Here's my x term, 2x over 3. To get rid of that division by 3, I'm going to times both sides by 3. Hopefully you're getting the hang of this now. 8 times 3 is 24. 2x over 3, when I times that by 3, it cancels the division by 3, so the 2x just pops out at the top. And then to get rid of 2 times x, to get rid of that multiplication by 2 in here, I need to divide by 2. So I'm going to divide both sides by 2, which gives me 12 equals x. And I will just write that as x equals 12. If you want to check it doing the other way, that would be a good way of doing this. And it'll practice all your different skills, which is great. And then you can be really confident in using either. And that's going to be helpful later on when the questions get more difficult. And also, if you get the right answer, you know you're going to be right, because if x is 12, you'll have got it right. And then 11, last one, 3h over 6 plus 2 equals 5. So again, find out where your unknown is. It's in this term. So I want to get this thing by itself. I want to isolate this. So get rid of the plus 2, and you'll do that by subtracting 2 from both sides. So subtract 2, subtract 2. That will leave me with 3h over 6 on the left, because it will cancel this thing. And 5 minus 2 is 3. Now look at my h term, my unknown term, division by 6. So I want to multiply by 6 to get rid of that division by 6. The 3h will pop out at the top, because the division by 6 and the times by 6 cancel, but I've got to balance by timesing the other side by 6. 3 times 6 is 18. And then last step, to get rid of that 3 in front of the h, 3 times h, I will need to divide by 3 to get rid of that multiplication. So divide the left-hand side by 3, leaves me with h. Divide the right-hand side by 3, leaves me with h equals 6. And again, check it the other way. Check that you get 6 as your final answer. And if you do, you're fully equipped to go on to the next videos. You can see these just take a few more steps. The principles that we learned in the first lesson, like this last bit here, that kind of one step, we've just introduced new layers at the start of the question. It's how we deal with those things, and it's always doing the inverse. If there's division happening in the equation, we can multiply to get rid of that. If there's addition happening, we can subtract to get rid of that. So keep watching the videos. Every time you solve equations properly like this, you are practicing the skills. So it all counts as revision. It's the best way of doing it. Don't try and guess what h is. It's probably already getting a bit too complicated to do that. There's a lot of numbers out there that you could be guessing, an infinite number, so you could be there all day. You're better off having a systematic, logical approach, so that you'll always get the answer in the correct fashion if you calculate the sums correctly. Hopefully you found this video interesting. If you like the video, please hit the like button, hit the subscribe button. There's lots more videos coming, lots more lessons on linear equations as well. Really fundamental skill for this. And yeah, thank you very much. See ya.